So after multiples, we can also introduce them to what we call factors of a number. Okay, by this we can also talk about the highest common factors. We can talk about the idea of the prime factorization, using it to determine the highest common factor. And how do we determine the other highest common factor of other numbers? We can also use it to determine the nature of some numbers. Okay, how some numbers behave, and give them some names. And this is what we are going to do. And so if I have the factors, I will say that a factor, if a number divides a second number exactly, then the first number is a factor of the second number. Okay? And so if I have a particular number and it divides a number exactly, then that number that divides that number exactly, the denominator becomes a factor of that. So for instance, if I have 12 and I divide 12 by 4 and it gives me a whole number, then the implication is that this 3, this 4 here is a factor of 12. And of course, the result that we are going to get is also a factor of 12. In other words, if I also multiply this 4 by 3, I'm going to get 12. And so you will notice that if I have a number 12, the factors are 1, 2, 3, 4, 6, 12. Okay? So I have 1 times 2 is 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Now if we have this, I'm going to draw a table, and this table is going to guide us to get so many things out of it. We have a number here. We can talk about a set of factors. We can talk about a number of factors. So I'm going to list numbers from 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can also continue from there. Maybe 13, 14. If you want to continue, you can continue. Now let's look at set of factors. Factors of 1 is 1. 2, we have 1, 2. 3, we have 1, 3. 4, we have 1, 2, 4. 5, we have the factors 1, 5. 6, we have 1, 2, 3, 6. 7, I have 1, 7. 8, I'll have 1, 2, 4, 8. 9, I'll have 1, 3, 9. 10, I'll have 1, 10, 1, 2, 5, 10. 11, I have 1, 11. 12, I have 1, 2, 3, 4, 6, 12. 13, I'll have 1, 13. Let me forget about this 14 because I cannot write it here. And then let's look at the number of factors. How many factors are here? 1. How many factors are here? 2. 2. 3. 2. 4. 2. 4. 3. 4. 2. 6. And 2. So if we're asked to determine what prime numbers are at this level, we can use this idea to teach them the concept of prime numbers. And we are saying that prime numbers are numbers with only 2 factors, the number and other factors. I mean, 1 and the number itself. 1 and the number is 6. So we can go through the table, look at the set of numbers here, and then maybe determine prime numbers from here. And so let's look at the prime numbers here. We can talk about 2 as a prime number. It has 2 factors. 1 and the number is 6. So 2 is a prime number. 3 is also a prime number. It has 2 factors. 1 and the number is 7. 4 is not a prime number because it has more than 2 factors. Let's talk about 5 is a prime number. 7 is a prime number. And then 11 is a prime number. 13 is a prime number. So if you continue on, from there, you can use this idea to tell them prime numbers may be between 1 and maybe 100. 1 is not a prime number. Remember, it has just a factor. But the prime numbers begin from here. Okay. Now we can also use this one to teach them what we call proper factors of a number. Proper factors. We are saying that when we talk about a proper factor, we are talking about the factors of a number without considering the number itself. So whenever we talk about the proper factors of a number, we list the factors of the number without the number itself included. You will notice that in all cases here, the set of factors of the numbers, whenever we write the factors of the number itself is included. If you look at 1, we have 1. 2, we have 1, 2. The 2 is included. 3, 1, 3, 3 is included, and so forth. But if you want to talk about proper factors, then what we are going to do is that we are going to write the factors of the number without including the number, without the number itself. And so when I talk about proper factors of 6, then I'm going to have it as 1, 2, 3. These are the proper factors of 6. When I talk about the proper factors of 8, then I'm going to have 1, 2, 4. These are the proper factors of 8. And these are the proper factors of 6. We are writing the factors of the number without the number itself. And that's what we call proper factors. And so from here, we can also talk about numbers we call the imperfect and deficient numbers. What numbers are called imperfect and deficient? Numbers greater than the sum of their proper factors. Numbers which are greater than the sum of their proper factors. And so if I add the proper factors of a number, and the number itself is greater than the sum of the proper factors, then that number is an imperfect and deficient number. That number is an imperfect and deficient. Imperfect and deficient. So we are saying that when you sum up the proper factors of a number and the result is not more than the number itself, or the sum is less than the number itself, then that number is an imperfect or deficient number. If the number is greater than the sum of its proper factors, then that number is an imperfect and deficient number. For instance, if you go through, you will notice that if I have the number 8, choose the number 8. Let's look at the proper factors. The proper factors of 8 are 1, 2, and 4. If you add these numbers, this plus this is 3 plus 4, 7. 7 is less than the number 8. And because 7 is less than the sum of the numbers, which gave you 7, and is less than 8, it means that the gate we chose is greater than the sum of its proper factors. Therefore, 8 is imperfect and deficient number. Okay? Now, apart from that, we can also talk about some numbers we call the imperfect and abundance. Imperfect and abundance. Imperfect and abundant numbers is the vice versa of the first one. That is, when the number is less than the sum of its proper factors. When the number is less than the sum of its proper factors. So let's go through and look for a number which is less than the sum of its proper factors. Let's look at this number 12. The proper factors of 12 are 1, 2, 3, 4, 6. These are the proper factors of 12. If we add these numbers, what are we going to get? 3, 3, 6, 4, 10, 16. 16 is greater than 12. And because the sum of the proper factors of 12 is greater than the 12 itself, 12 is an imperfect and abundant number. Okay? So when we use this, we can ask the children to explore and then challenge them. If they write the numbers down, they can get so many numbers. And then we can also have proper numbers. We can also have proper numbers. And if a number is a proper number, then it means that the sum of the proper factors is equal to that number. The sum of the proper factors is equal to that number. We talk about perfect numbers. We call them the perfect numbers. Perfect numbers are numbers whose proper factors will be equal to that particular number. Let's take, for instance, this number 6. If you take the proper factors of 12, of 6, if you have 12, we are saying 12 is a perfect number. Because if you have the sum of its proper factors, and what are the proper factors of 6? We have 1, 2, 3 as the proper factors of 6. If you find the sum of these proper factors, they are going to give you 6. And of course, 6 is equal to 6. And because of that, we say that 6 is a perfect number. So now we can ask the students to explore and know more about the numbers under consideration. Okay. Now, we can also talk about highest common factors. And normally we find it between some numbers. And so if you want to find the highest common factors, maybe you want to find the highest common factors of 24 and maybe 16. And so what we need to do is that we guide the children to find the factors of the numbers. So they will list the factors of the numbers. So let's look at the factors of 24. We have 1, 2, 3, 4, 6, 8, 12, and 24. Let's look at the common factors, the factors of 16. We have 1, 2, 4, 8, and then 16. After you are done with that, you guide the children to list the common factors. So common factors. So they will list the common factors. The common factors are 1, 2, 4, and then 8. These are the common factors. When they are done with that, because the focus is on highest common factor, they look for the highest common factor. That is the number that is highest among the common factors. And in this case, this is the same as HCF. And in this case, is equal to. Okay. I hope this one we can all do that. So you guide the children to list the factors of the numbers. Let them pick the common factors out of that, and then let them get the highest common factor of that. Okay. Now, if I don't want to use this, I can also use what we call the factor tree or prime factorization to do that. So let's see for the 24 and the 16 how we can do that. So if it is 24, I'm looking for prime factors of that. So I have 2 times 12, 2 times 6, 2 times 3. So in effect, this is going to give you 2 exponent 3 by 3 exponent 1. Okay? Then let me look for that of the 16. So 2 times 8, 2 times 4, 2 times 2. And this one is giving me 2 exponent 4.